Hello everyone, and welcome to the AI Research Roundup. I'm your host Alex, and today we're diving into some really interesting AI research. We'll be looking at a paper titled olmOCR, Unlocking Trillions of Tokens in PDFs with Vision Language Models. The core idea here is that PDFs are this huge untapped source of text data, potentially trillions of tokens for training language models. But PDFs are tricky with all their different formats and layouts. So this paper presents olmOCR, an open-source Python tool that uses a vision language model to pull out clean text in the right order, while keeping structure like tables and lists. Yeah, so handling that kind of varied structure is exactly the challenge. This image here gives a sense of what we're talking about. You can see it shows things like, well, an equation at the top, a section heading, and importantly, a table formatted in Markdown here. The goal of olmOCR is to look at a PDF page that might contain elements like these and not just pull out the words, but understand that this is a table, this is a section, and preserve that structure in the final text output, keeping everything in the right reading order. Right, and this image here really illustrates how olmOCR tackles that structure preservation. It's showing a technique they call document anchoring. So on the right, you have the original PDF page, and on the left, that's the special prompt they create. It's not just the page image. It also includes text blocks pulled directly from the PDF along with their position coordinates. You see those numbers in brackets? This gives the vision model both the visual layout and this anchored text metadata to work with, which helps it understand the content and order much better. Okay, so digging a bit deeper into how that anchoring works, this figure gives us a peek under the hood of a PDF itself. It shows that a PDF doesn't store text like we usually think of it, like the word olmOCR. Instead, it stores each character O, L, M, and so on, individually. And for each character, it stores metadata like the exact position on the page. See those matrix numbers? And the font information. This is the kind of detailed, born digital metadata that olmOCR pulls out using tools like PyPDF and uses as anchors for the vision model. Okay, and building on that idea of extracting metadata, this figure gives a more complete picture of how document anchoring works for a typical page. On the left, you see the actual PDF page, and on the right, that's the structured prompt olmOCR creates. You can see it includes not just the image reference, but also specific text blocks extracted directly from the PDF, like figure 1 foot or introduction, along with those positional coordinates we talked about, like backquote 71 by 459, backquote. So the VLM gets both the visual page and this precise anchored text. So to train a model that can handle all this variety, you need a diverse data set. And this table here, Table 2, gives us a breakdown of the types of web PDFs they used in their training data. You can see it's heavily weighted towards academic papers, about 60%. But they also included a good mix of other things, like brochures, around 12%, and legal documents at 11%. This kind of mix helps ensure the final olmOCR model is robust across different document styles. Right, and this table here, Table 1, gives us a clearer picture of the overall training set composition by source. We just talked about the types of web PDFs, but this shows where they came from more broadly. You can see the bulk comes from those web-crawled PDFs. Nearly 100,000 unique documents making up about 250,000 pages. They also added a significant chunk from Internet Archive books, over 5,000 documents and nearly 17,000 pages. So in total, they built a pretty substantial data set, well over 100,000 documents and more than 260,000 pages to train olmOCR. So after putting together that diverse data set, the next step was figuring out the best way to actually train the olmOCR model. This figure here, Figure 3, shows a comparison they did during training. It plots the evaluation loss, that's the vertical axis, against the number of training steps. They compared two methods, full fine-tuning, shown in yellow, and LoRa, shown in orange. As you can see, the yellow line consistently stays lower, meaning full fine-tuning achieved a better validation loss. That's why they ultimately went with full fine-tuning for the final olmOCR model. So yeah, choosing full fine-tuning really optimized their olmOCR model. And that wraps up our look at this paper. The big takeaway is how olmOCR uses a vision language model trained on that massive diverse dataset to effectively pull text and layout from PDFs. This is super important because it opens up a huge amount of information previously trapped in all those PDF documents for AI systems. Well, that's all for this episode. Thanks for listening to the AI Research Roundup. I'm your host, Alex.